Hello, my name is Mario. Welcome to another Learning Go video. In today's episode, we're going to be talking about relational databases, specifically about transactions. As usual, the link to the code will be in the description of this video, so feel free to check that out. This specific episode is going to be based on what we learned before with the introduction of database SQL. I'm going to be showing you two different ways to use transactions using both database SQL and a concrete implementation of the PGX package, which happens to be the driver for Postgres. To start with, let me show you the schema that we are using. Just a reminder, we have a schema called that is going to be using only a table called users. There is a name and a birth year as the columns in that table. Important bits to remember will be that name is the varchar, not null, and birth year is a small int, null, default 0. This is important because we're going to be using a few things to make it fail, and therefore I'm going to be explaining you why transactions are really important. So let's start by showing you that we don't have anything in the database, we don't have any values in the table, so everything is fine. So like I said, we're going to be working on what we built before, so we're going to be refactoring the final example that I showed you previously in the previous episode. So let's start with something. We're going to be taking the data or the calls that we have here related to the connection. Just for the sake of cleaning that up, we're going to be extracting that information and creating a new function called new DB, and this is going to be important when I show you the other implementation, and that happens to be using PGX. Now remember, the idea of defining transactions, or rather using transactions, is a way to indicate how multiple statements, either SQL statement, or rather, obviously everything is SQL, but I mean select statements or update or insert or things that change or read are executed as a all or nothing kind of action. So if any of those actions fails, everything fails. So in order for all of them to succeed, all of them have to succeed. And the whole point of using transactions is when you want to modify different or call different SQL statements, you can execute those as one in a single way. Now, I have this that I want to just refactor because I want to clean it up a little bit, and just please bear with me right here. So if you remember, when you are dealing with errors, you need to be using the new API that includes the wrap function, the wrap verb that I covered previously in another episode. So I have the new DB right here, and I want to clean. What the heck happened? I want to clean this up, so I'm going to have DB error new DB, and typically everything goes fine. I'm going to remove a few things just to make this a little bit easier to follow. Again, most of these things we cover in the previous episode, so don't worry too much about it. It's just I want to make it the smallest example as possible as we can. So we have if an error, just print error, new DB, and error message, and return. So everything seems to be working, everything seems to be compiling. Nothing is doing it's not doing anything in particular. So let me go to my 2021-11-26. So right here, like I said, I have a standard library example and the other one as well. So if I run this, it's not going to be doing anything because we haven't implemented the transactions. Again, like I said, the whole point of the implemented transaction is to execute a bunch of different instructions as all of them together. If one of them fails, you revert the whole thing. So in SQL, there are 3 commands that are executed for dealing with transactions. Will be begin, commit, and rollback. If you're familiar with SQL, when you're executing those commands, you need to begin, which is basically beginning of the whole transaction. If everything goes fine, you call commit. So everything that happened before that, it will be saved into the database. If for whatever reason you think something went wrong, you can call rollback, and that literally will not execute or save any of the changes that you previously called in the lines above of your SQL statements. In Go, the way it works is by using a type called Tx, which literally means transaction. So the way it works there is a function called BeginTx, and begin. Remember when we were discussing previously in the introduction to DB.SQL, remember that the context package was added a few years after this implementation of the standard library was available. So now we have a few different functions that apply to the type that receive a context type from the context package. So we're going to be using all of them like we did previously. So in this case, we're going to be defining and calling begin Tx to define a transaction, and what this returns is it returns a transaction and an error, and it also receives a Tx options. And this depends on your driver, how you want to somehow isolate the transaction. And again, this goes back to the way the drivers are implemented and the database engines are again implemented and documented. So in this case, we're going to be using the default configuration just to keep it simple. And like I said, it's going to be return type Tx and an error, and we're going to be doing our typical error checking. So DB.BeginTx and just failing and returning, and that's it. Now, like I said, in SQL, in relational databases, begin, commit, and rollback are our friends. So we have the begin instruction. What we will be doing either next will be calling either commit if everything goes fine, or rollback if anything goes wrong. Now, what could go wrong is up to the database, not something that we're. You can also maybe validate the input that you're receiving in some cases if that's what you want to do. But typically, what you do when you are using rollback or commit is if any of the database instructions fails when you're literally accessing and calling the database, is when you call commit or when you call rollback. Now, let's go back to the example that I showed you before, or another example, but the schema that we had before is that we have a create table users with name and birth year. All right. So what we're going to be doing, we are going to be doing a typical. Let me extract that out into another function so we can make it more. Let's call it insert users. And what insert users is going to be doing the transaction stuff. It's going to be receiving the database type, and maybe a slice of users that we're going to be defining here. Let's call it users, and it's going to be returning an error. Now, obviously, the type user does not exist, so let's go define it. We have a type user struct. We have a name, a string, and a birth year, which in this case would be an int 8, which is equivalent to the small int in Postgres. So we have a slice of users, and then we're going to be inserting all of those users in a transaction. And I want to use example that is going to be working for in the beginning, and then I will show you how this thing works nicely when you are working with transactions. So you have again Tx exec context background insert into users name birth year values, and again we are using the placeholder dollar placeholder and the values as well, which will be user name. What the heck happened? User.name, user.birth year, and this returns if you remember the documentation, it returns, let me clean this up so it doesn't complain. So it returns a SQL result and an error, and SQL result will be the ID and the error will be the error. For now, we don't care about the result, we only care about the error. If error is different than nil, we return error fump error f Tx exec context, and then we wrap it and return nil. Now, we haven't really called commit or rollback yet, so what we're going to be doing is if we call Tx.Commit because we assume everything seems to be working right here. If error and commit returns an error, if error is different than nil, we do something similar. We do the checking, fump error, and Tx.Commit the wrap error and whatnot. So with this in place, what we need to check is what is going to happen if any of these statements fail. So that's when rollback comes in. Oh, one thing I have here is incorrect. So I need to fix this to return an error f wrapper and an error. And then if everything is fine, just commit the message and whatnot. Now, typically the paradigm for when you're dealing with transactions, you need to call rollback no matter what. And this is one of those kind of confusing things in the beginning because the documentation is not clearly explaining that, and this could depend on the driver. But most of the times what you can do is after you begin the transaction, you can invoke defer with the error, or rather with the rollback that will be executed in case anything goes wrong. And this doesn't mean that when the conclusion of when this function completes, it will call rollback. I mean, it will call rollback, but it won't roll back the transaction because the transaction is already committed. So what this means is that even if something goes wrong, rollback will be called because commit failed, and therefore the defer is invoked. Okay. Now let me run this for you, and you will notice that this should be working. Nothing should be going wrong. So I have my go run. If I do a select from users, I don't have anything installed, right? Oh, you know why? Because I didn't call insert users. So if error insert users db, you have a slice of users, error is different than nil, your typical error checking, fm print ln insert users error, and then we can add a user, which in this case will be name Mario, birth year 1900. So if I run this again, constant overflows int 8. Okay, let's change it to int64 just for now. I'll revisit this in a moment. So everything goes fine, and now it's inserted into the database. Now let's go back to the way the database schema is implemented for this table specifically, and you notice that name is a not null and birth year is a nullable type. So what this means in practice is that we can use pointers for both of them. But what is going to happen in the database is that if we send a nil in the name, it will trigger an error. So in order to show you an example of that, let me change the types that we used before for name and for birth year. We're using pointers now, and what we're going to be doing just to use a simple helper functions, we're going to be using some anonymous functions right here that take an input, which will be a string, and return a pointer of what we had before. So we have name, birth year. Change this one to uppercase, fix this one, let's call it B in 64, 77, 74, that doesn't make sense. Now in 64 and B, and if I I do this, oopsie, if I do a new name Mario, new birth year 1900, let's put Mario 1. If I run this again, it will work. If I run the select, it will work. But here's the interesting thing about all of this. If I go ahead and take an invalid value in the context of the database, because the constraints that I have right here, it's my name has to be not null. If I decide to pass in a nil value, what is going to happen is that it's going to be failing. Okay, and this instruction that I define above, that is in the slice of users, will not be called, which will be this exec. So to rephrase it, we're trying to insert two records into the users table. If one of them fail, or if any of them fail, nothing is actually inserted into the database. And this is the whole point of transactions in the relational databases. Like, you take a bunch of different instructions and it's all or nothing. And this is the whole point that we're trying to demonstrate right here. Again, I go here and I run my run my command, my main, and it says my error. The name violates the not null constraint, which is the thing that we have in our schema. It says it's not null. And if we go back into and show you the content of these users, it does not show that. Now, why is this important? Like I said, it's all or nothing. Let me refactor this a little bit, and let's say we are not using transactions. We are using your typical database exec context. I'm going to comment this out just for demonstration purposes. But what is happening now, if I change it, is that I'm receiving a slice of users, and I'm inserting each one of them using the database type and calling the insert. If one of them fail, whatever happened before that will still be inserted into the database. Now, again, we have the users. If I run this again, you will notice that now, sure, I'm getting the error, but if I go back to the users, now I have 3 users. And that's not something that we want to do, and depends on the business logic that we have. We're trying to achieve sort of like a one single execution of all the calls that we have in our program. So that's why transactions are really important. So let me show you another example using PGX specifically, the API that is included in that package. And it's, I think, in my opinion, a little bit easier to follow and cleaner. So let's see. So typically, not all the drivers provide a way to access databases, relational databases, that is, outside of what DB.SQL already provides. But PGX is a different, an interesting example of how a package could be implemented for accessing databases. So what I did here, what I have here for this third-party package specifically, this module rather, in this example, is I'm going to be taking what we did before. We're going to be refactoring a little bit to not use database SQL in the standard library, but rather use the PGX actual package. Not the package, I mean the type that is coming in that package. So one thing I'm going to be doing is getting rid of this this package import. We remove the the empty import, and the other thing that I'm going to be doing is going to be renaming this Conn neodb to neoconn, and the reason being is that we're going to be returning a PGX Conn type, and everything sort of stays the same except for the PGX called to connect, and it receives the same DSN. Nothing changes on that end. Maybe we can just change PGX connect just to make it clearer. We call Conn and we call Conn. Now what's happening here is that I'm missing something. So you remember, the documentation is your friend, but I remember that this one is using the methods that are defined in the PGX API. They're actually, all of them define a context as the first argument, like the ones that we saw previously in database SQL. Now all of them already do that before already, because that's sort of the new convention that we have to use for accessing or try to using context-based methods and types, just to pass in cancellation, errors, propagation, those kind of things. But anyways, so let's go back to where Conn is being used. So Conn will be renaming this just to make it clearer, and similarly to close, now it receives a context as well. Now the biggest difference with the way it is with database SQL is that you can still use BeginTx, commit, and rollback. However, the cool thing about the Conn type specifically is that now it defines two different functions, or rather 2 different methods that wrap the actual transaction in one function, so you don't have to deal explicitly with by the need of calling commit or rollback or those kind of things. So I think it makes things a little bit easier, and I want to show you the way it is right now. So let me just refactor this thing. So we are receiving a Conn right now. This variable now is called Conn. And rollback is still a context. I'm just trying to remove all the warnings that you can see that my editor is literally just highlighting those errors and whatnot. So what I have already defined is this will be the equivalent of what apparently this is not correct. Let's again, documentation is our friend. So we have a context pgx error tx. So what is the problem? Oh, because context.context is that doesn't exist. So we have context background, and we do, what the heck is going on with my editor? Anyways, so context background, and now everything seems to be working. There's nil. We don't need this one. Is that how it is? Begin. Oh, I see. So again, the APIs are different. PGX, TX options, which will be used the default options. If I build this, everything is building. Okay. Now that I refactor everything to use the PGX Conn type, I want to show you what I wanted to show you in the beginning. So everything is basically the same implementation, right? You have a begin tx, a rollback, and you are calling exec for inserting the values that we defined previously. The cool thing about Conn when you're using this type is that you can actually use two functions, either BeginFunc or BeginTx Func or I mean, there are actually three of them. Yep, three of them. So what happens with this is that when you use this function, you indicate a function as well that it will be used as a way to, if you return error, to either commit or roll back the transaction. It also uses the context as well to determine whether commit or roll back the transaction as well. The one I want to show you, I mean, both of them are practically the same. It's just the difference will be that, for example, begin tx is actually using an options, and begin begin tx.Func is receiving a tx options argument for defining transaction options like isolation or read level, those kind of things. And BeginFunc is the one that is actually not receiving that. So for now, let's use this one in particular. So we have context background, and the type will be func tx pgx tx, and return an error. And that's basically here. We have an error right here. Error is different than nil. Return fump error f Conn.Begin function, the wrapper error. And what we're going to be doing, as you may be guessing already, is literally use copy, alright, cut all of this, move it up here, and return the value. If there is an error, we just return that error, and everything goes away. So it's sort of like a much more cleaner, not cleaner, but shorter. So this is tx. Why is tx complaining? Oops, of course, this shouldn't be here, or rather inside this one. So what I did, again, to recap, we have a function. Yep, I think so. It seems to be an error. Let me see. Return. Oh, of course. If there is no error, you return nil. So again, to recap, so we have a function called a method in the Conn type called BeginFunc that could be used for either BeginFunc or BeginFunc tx, BeginFunc or BeginTxFunc rather. Tx.Func receives an argument for defining options for the transaction, and the other one will not receive any arguments for the transaction. It will be using the default configuration. What it does is literally wraps the transaction in a function. If the function returns a non-nil value, it will roll back the transaction. If it doesn't, it will just commit the transaction as expected. It still uses the context as a way to deal with error propagation or cancellation, and everything stays basically the same. Now if I run this, let's compile it. Everything seems to be working. Let me select my users. What is going to be happening is one of them will be failing because the transaction error. So let me go back and fix that for us. So a new name, let's call it PGX1 and this PGX0. So if I run this again, you will see that now name is, what is saying? Conn violates non-nil value. Why is it? I didn't save this one. Oops. Typical rookie mistake. So I was using a different folder, a different file. So if I run this again, everything will be fine. So what I was running before, I was using the std.lib example instead of the one for third party, which is the PGX example. So again, PGX0, PGX1, everything should be working. Everything is fine and dandy. And let's jump into the final conclusion right here, because what I want to show you and what I want to discuss finally is that, again, transactions are really important when you're trying to do multiple actions in the relational database that you consider as all of them have to be executed or none of them should be executed if any errors happen. You should be really careful when dealing with transactions, because as soon as you open a transaction or as soon as you begin a transaction, you should be using that transaction type as a way to communicate with your database. You shouldn't be calling the database that you previously was called for creating the transaction. 3, depending on your driver, you could have access to an API like the one I will show you with BeginTx, and that's it. I mean, hopefully all of this was useful, and thank you for watching. Any comments, any thoughts about transactions in Postgres, please let me know. I will be covering also, like I said in the previous episode, MySQL in the near future. So stay safe, take care, and I will talk to you next time. See you.